Hello everyone and welcome to the channel. In this video, we're going to run a quick lab and test a couple of things using access lists. The idea for this video is inspired by something I discovered at work. For the purposes of this video and demonstration, I'll be using my simple EVE-NG lab consisting of 4 routers. This has nothing to do with any production environments that I work on. This is simply a creation of my own imagination with random IP addressing as well. And we don't actually even need a complex production environment for this purpose. A simple topology will do just fine. Alright, so let me try to explain simply what we're going to investigate today. So let me pull out my pen tool for this. Now we'll use R2 to configure the access lists, and I'll explain the scenario. So here's the trick. We'll configure an access list here, and we'll do it in the inbound direction, although it doesn't really matter. My typing doesn't look so great today. Anyway, hopefully you can read what I just wrote there. So now what I discovered at work was an empty access list configured on an interface. And what we want to find out is how that would behave. Will it pass traffic through or block it? And also we'll want to examine if the behavior is different, whether that access list exists at all. So let's write that down. Number 1 is an empty access list, and number 2, no access list. So before I jump on the command line, let's think about how this would work. Now, normally when you configure an access list, you would build it in the following way. So you would have something like permit. Actually, we don't even have to make up anything for it. It doesn't matter, but a bunch of permit statements and perhaps even deny statements followed by more permit statements. It really depends on the situation. But at the end, you would have the implicit deny statement, right? That would catch and block all traffic that is not allowed in the access list. So now here is my theory. If you remove all the statements and you leave an empty access list, technically that implicit deny statement is still there. Logically, that's how I would see it, but again, this is just my theory, and we're going to look at this on the command line shortly. So in other words, if I take out all this, then we're left with only this implicit deny statement. Now, on the contrary, if you don't have an access list, but there is still a command configured under the interface, then perhaps that shouldn't affect the traffic because nothing is attached to it. It's kind of an empty command, if that makes sense. So again, this is my hypothesis, this is my theory that we're going to test. So in summary, my guess is that an empty access list would block all traffic, and then no access list would pass all traffic. Okay, but we're gonna find out. Let's jump on the command line. Let me just get rid of this first and then close this. So let's jump on R2. Okay, let's wake up the router and do enable. I have OSPF configured on all these 4 routers so that they're advertising the routes, and I actually forgot to mention that they have those loopback interfaces configured with the interfaces that, or the IP addresses that were mentioned here. And these are also the router IDs for OSPF. So if I go back here, and if I do show IP OSPF neighbor, and I mistyped it, there you go. As you can see, neighbor IDs 1.1.1.1 and 3.3.3 R3.3. Now you might actually wonder, why would there be an empty access list configured on the router? And I think the reason behind must be that they wanted to monitor certain type of traffic temporarily, but they forgot to delete all the configuration. So we'll try to do something similar. Let's actually go back to the topology real quick. So let's say that we want to figure out what's wrong with communicating between R1 and R3 using the loopback interface addresses. So we'll configure that in our access list and deny pretty much everything else. We'll still allow OSPF traffic, so the OSPF neighbors will not go down and the routes will continue to be advertised so that the devices can reach each other. Okay, so let's go back to R2 again. All right, so let's create an access list. For that, I need to go to the config mode. And let's see if I remember this by heart or if I need to use the question mark a lot. So let's say IP access list extended, and we'll give it a name, a kind of a gaming term. And then, as I mentioned, we'll allow OSPF traffic. So permit OSPF any. And then we'll permit host R3. And I forgot IP from here. We want to allow all protocols. And then host 1.1.1.1. And we'll log this, so we can see when traffic hits that rule. Now, as I mentioned, at the end of the access list, there is an implicit deny any statement. Now, I'll type it here just to show you how it looks like, but I'm not going to apply it to the access list. So it would look something like deny IP any. But again, I won't hit enter here, so I'm just gonna delete this. All right, so there's our access list. Now let's exit this. And actually, let me do show IP interface brief. I'm just double checking that I'm applying it on the right interface. So gig 0/0. So let's go under the interface. And then we'll do IP access group. And then let's double check the syntax. So here we put the name, and then after that, the in or out direction. So we want it in. And let me just show you why. Because we're gonna ping from R3 to R1. So the traffic is coming from this direction. So it's gonna be inbound for R2 gig 0/0. Okay, let's go back here. We'll apply that. And we should be good to go. That access list is applied on the interface now. Okay, so let's go on R3 to check if our access list works. So we'll do ping 1.1.1.1, but we have to specify the source so that it's going to come from the loopback address. Success, and let's see what happens on R2. So you see here that the ping was permitted. I don't know why it says only one packet, because we sent 5. Perhaps it counted only the first packet in the traffic flow. I'm not sure about that. If you know the answer, let me know in the comments. So here we can double check that we actually sent 5 packets. 5 exclamation marks, 5 successful ping packets. If we just ping R1 without specifying the source, it's not gonna work. Let's test that. Yeah, we're getting those U's to see that it's unreachable. But now we shouldn't see any log messages on R2 because we didn't specify a statement for that. And it's not automatically going to log something that hits the implicit deny statement. But we can verify from the command line. Yeah, there's nothing. Normal log messages. So now let's test what happens if we remove the statements from the access list. So effectively it becomes an empty access list. Now, as I guessed at the start of the video, an empty access list should not allow traffic to pass because technically that implicit deny statement is still at the end of the access list. But I also have to say that if it were to behave that way, there's also a huge downside because then it would block all traffic. So effectively that interface would be unusable. So on one hand, it doesn't make sense for it to behave that way, but on the other hand, it kind of seems like it could because of the implicit deny statement. I keep bringing that up, but I just want to stress how important it is to understand that that is at the end of the access list. Anyway, let's test that. So let me just type show IP access list. Okay, so let me go back to config mode and then IP access list extended and then this funny name. So let me copy the statements from here. So we want to remove these statements, but we don't want to entirely delete the access list just yet. Oh, why do we get this log message now? That's strange. Okay, if you have an answer for that, feel free to let me know in the comments. All right, let's move this other statement. Okay, so now, so we should have an empty access list. Indeed we do. You see that it is mentioned there. And it is still applied on the interface. So if we do show run interface gig 0/0, so you see that it's still applied here. And actually, let me see if I can also check that with the other commands. So show IP interface gig 0/0. Let's see if it's anywhere here. Yes, right there. And just out of curiosity, let me see if it shows it without the IP parameter. I don't think it should because technically this information is for layer 2 and the IP command is for layer 3. And no, I don't see it here. Okay, anyway, so let's look at the interface configuration again. So the access list is still applied on the interface, but it appears that it is not blocking any traffic because our OSPF neighbors are still up. Let's just verify that. Show IP OSPF neighbor. By this time, they should have gone down. And actually, you can see the dead timer there is 38 seconds. So it means that a new hello packet was received just a couple of seconds ago, which reset the dead timer. But let's go back to R3 to verify that. So let's do another ping here. It doesn't really matter if we use the source or not in this case. So it works, which means traffic is allowed despite there being an empty access list applied on the interface on R2. The same will hold true with the source command. So that means my hypothesis or my theory or my guess was wrong. Seeing how this works, there will probably be no difference if we remove the access list from the interface entirely. So let's test that as well. So let's go back to R2. We'll go to config mode, and then under the interface, and then we'll remove the access list. Sorry, I'm doing it all wrong. Of course, we can't remove this command because then it means that no access list is applied on the interface. So of course it's not blocking any traffic. So what I meant to do is, no IP access list extended and then the name. So now show IP access list, there's nothing. But once again, the command is still applied on the interface. So right here. And let's go back to R3, see if the pings still work. They should. And indeed they do. So no difference here. Okay, let me go back to the topology. Let me take out the pen tool again. Oh, I forgot to erase this information, but it's actually good that it's still here because we can reflect on it. So you'll notice here that number one, my guess was that an empty access list would block traffic. Well, this turned out not to be true. So this statement right here is wrong. So it actually passes traffic. And then number two, my second guess was that no access list would pass traffic, even if the command was still applied on the interface. And this turned out to be true. So let's put a little question mark or a check mark here. So this thing is a little bit messy here, so let's just type that one more time to let that sink in. So empty access list, it'll allow traffic to pass, and no access list does the same thing. Allow. Now, I don't know if there's any difference between different versions of iOS. I mean, between different code versions or different iOS versions like iOS XR or NXOS. Once again, if you have any thoughts or ideas on the matter, the comments are open. But otherwise, I hope you have enjoyed this Discovery Lab and found some useful information. If you made it this far in the video, I appreciate it very much. Thank you for watching, and I'll see you next time.